Hello Science Fam, we are back with part 2 of ionic formula writing and naming. We wanted to start off with talking about a type of ion we have not addressed yet, and those are called polyatomic ions. The prefix poly means many, like a polygon has many sides. So a polyatomic ion is something that has a charge, that's why it's called an ion, but it's more than one atom that's stuck together. So for example, you'll see that their names are different than what you see on the periodic table, or like fluorine by itself as an ion is just called fluoride. Polyatomic ions are going to end in ITE or like ATE, ite or ate, things like that sometimes. So just a heads up on that. But anyways, something like the polyatomic ion acetate has a -1 charge overall. But this whole thing has to be grouped together in order to have that -1 charge. So when we're using these polyatomic ions, we never change anything inside the parentheses. They all come along for the ride. So it's easy to get overwhelmed and say, whoa, there's 3 different elements here. What do I do with all those? Nothing. You keep them absolutely the same. So you always keep them, just throw them in parentheses, and overall, that group of elements has a -1 charge. Something like nitrate versus nitrite. They sound very similar, but they are slightly different. Nitrate is NO3, and when they're always stuck together, it has a -1 charge. Nitrite is NO2, so it always has 1 nitrogen and 2 oxygens stuck together, and if that's the case, it has a -1 charge. Something like hydroxide has an oxygen and a hydrogen stuck together, and overall, it always has a -1 charge. Something like cyanide, which you've probably heard of before. Unfortunately, cyanide is carbon and nitrogen stuck together. They put them in parentheses, but it always has a -1 charge. So these polyatomic ions, you might be thinking, well, how do I know these guys? But you're going to know them just from our ion reference list. So you'll have a link to it, and also you can grab a paper copy in class if you're in school. But ions are all listed here, the ions that we'll use in class. You'll see there's a mixture of them from like acetate, which just is a polyatomic ion, but then there's like the aluminum ion, which is just aluminum 3+. So this will be a super important reference for you guys so that you can figure out what all the charges are on the different ions for ionic compounds. So we're going to get used to this and notice that it's in alphabetical order. So as long as you have an idea of what the name starts with, it's easy to find. So for example, I'm going to make an ionic compound with oxygen. All right, I'm going to look for oxygen, and when I'm in the O's, I see, oh, there's oxide. And that's right, oxygen turns to the name oxide when it becomes an ion. So that means it has a 2- charge. So we'll be able to use this reference list, and I think it'll be very beneficial to you. All right, so now that we've talked about anions and cations and polyatomic ions, the ones that are grouped together, let's start getting the naming down. So remember, if you recall, when we look at the formula, the cation is always first and the anion is always second. That's positive first, negative second. So when you get a compound like AgCl, how are you going to name that? Well, the first thing you do is look at Ag. Okay. Then look on that ion sheet we showed you. Ag, right, is the element silver. So when we look on that sheet, it says Ag is the silver ion. Now, Cl is chlorine. So when we look on that chart, chlorine's name changed to chloride ion. So now that we have those two names, the silver ion and chloride ion, we are going to drop the name ion and just put those two words together. So it's going to be silver chloride. So it's as simple as that. Once you get that reference sheet down, it becomes very straightforward. You just got to look and say Ag, up, that's silver, chlorine, up, okay, chlorine, we change it to chloride, boom, that's what we're going to name. Notice we didn't say monochloride or anything with prefixes. We do not use prefixes when it is an ionic compound. Now you might be asking, well, how do I know if it's ionic or not? Remember, you've got to have a metal in it. A metal and a nonmetal make it ionic, and silver is definitely a metal. But again, no prefixes. So what if you come across a compound like this and you go, whoa, that's a lot of elements. I don't know how to name that. This is impossible. No, it's not. Relax. Take a look and see if there's anything you can group together and make a polyatomic. That's probably what it is. So when I see sodium by itself, I think, okay, yeah, sodium, there's two of them, but sodium is something I know that's just a metal. And then if you look SO4, SO4 is a polyatomic ion. It's actually called sulfate. So at first this might be a little different, but as you get experience, you're going to start to recognize the different polyatomic ions, and you start to see it with your eyes right away. But let's look and say, okay, Na is sodium ion, okay? Doesn't matter that there's two sodiums there. We're just looking at what the name of it is. And the anion here is SO4. When I look on my ion reference sheet, that's called the sulfate ion. All right? So as we know from the previous example, we drop the word ion. In this case, we drop the word polyatomic. We're just looking for their names. That's sodium and sulfate. So that compound is called sodium sulfate. Notice I didn't say anything about the two sodiums, like I didn't call it disodium or anything like that. And then also, people are like, wait. If there's SO4, don't I have to say anything about the four oxygens or call it like sulfur tetraoxide? Nope. Remember, this is a polyatomic ion. The SO4 sticks together. So that whole thing stuck together has one name, sulfate. So we just call it sodium sulfate. That's it. Okay, let's look at the next example. We've got FeCl3. All right, if we look on our chart, we'll notice that there's more than one iron. There's an iron 2 and an iron 3. So when we name this, we have to ask ourselves, yikes, what charge is this thing going to be? Is this going to be iron 2 or iron 3? So at least we know Fe is iron. Let's worry about the 2 and 3 in a little bit. Cl, there's 3 of them, but chlorine, the element by itself, which is an ion in this case, is chloride. So the question is, how do I know whether iron is +2 or +3? I know it says +3 here, but how do I know that? Well, it's not too hard. If we look at the formula, it has 3 chlorines for every 1 iron. All right, so here's a little puzzle. If each chlorine has a -1 charge, and how did I know that? Well, I just looked off of my ion reference sheet, or I could look on the periodic table and know that it's in group 17. Group 17 always has a -1 charge. But if I need these guys to equal 0, I've got 3 -1 chlorines, so iron has to have a +3 charge. Why? Because that +3 charge on iron will cancel out with the 1, 2, -3 charges from chlorine. So that's why iron has to have a +3 charge. So when we name iron, because iron can have more than one charge, it's a transition metal, we have to call it iron 3. Chloride, we always call chloride. So in the end, we call this iron 3 chloride. Pay attention again. Notice we didn't address the fact that there's 3 chlorines and call it like trichloride. There are no prefixes. You just use the name of the ions, and from the charges you could eventually write the formula, and we'll get to that here in just a second. So when writing formulas, it's a little different of a routine, but the main goal, remember, is a neutral charge, meaning we want the charges when they add up to equal 0. That's like something simple like sodium with a +1 charge and chlorine with a -1. Just come together 1 to 1 is sodium chloride, because positive and -1 added up equals 0. So that's what we're going to do. As long as we follow these steps, writing the formulas becomes very straightforward. Let's try the first example, sodium sulfide. So, just because you don't know it off the top of your head doesn't mean it's impossible. Let's just start looking at our ion sheet and figuring things out. So first of all, I see sodium. Sodium ion, when I look on my sheet, means it's a sodium with a +1 charge. Okay? Sulfide, when I look on my ion sheet, is a sulfur with a 2- charge. So the first thing I have to do is detective work and figure out what the charges of both ions are. So I know sodium's +1, sulfide is 2-, so now I can go to my next step. So step 1 we're done with. Next is step 2. Now you need to figure out how many of each ion there is in order to equal 0, meaning that they become neutral. So let's think about that. If sodium is +1 and sulfide is 2-, How many of each do I need to equal 0? Well, I'm going to need one more sodium plus 1 so that those plus 1 cancels out with the negative 2. So in the end, I'm going to need 2 sodiums for every 1 sulfur. So when I write out for step 3, my equation, I'm going to write that I need 2 sodiums for every 1 sulfur. And that's why the formula ends up being Na2S. So when writing ionic formulas, as long as you know the 2 ion charges, you can figure out how many of each you need so that it equals 0 charge. Remember, that's what you're trying to go for. Absolutely no charge. Let's try another example like iron 3 sulfate. Iron 3 sulfate, let's start doing our detective work. So let's look at the first ion, it's iron 3. When I look on my ion sheet, iron 3 is Fe3+. Okay. Next, I'm going to look at sulfate. On my ion sheet, sulfate is, it's one of those polyatomics. It's SO4 in parentheses with a 2- charge. Okay. So now that I have those ions, I want to figure out step 2, how many of each do I need so that they cancel out and equal 0? Well, let's do a little bit of work here. If iron is 3+ and sulfate in parentheses is 2-, how many of each do I need so that they end up equaling 0? Well, 3+ and 2-, if I get another sulfate, unfortunately 2- and 2- gives me a -4. So that's not going to work. So what if I add another iron? Now I have a total of 6+ for a positive charge. Okay. If I add one more sulfate, now I have 2-. If you really look at it, 2-, 2-, and 2- all equal a -6. 3+ and 3+ equal a +6. So the beautiful thing is the +6 and -6 cancel out. So it looks like I'm going to need 2 irons for every 1, 2, 3 sulfates. So that's why when we write this out, we end up saying it's going to be 2 irons, so Fe2, and we're going to write 3 sulfates. So remember, we put SO4 in parentheses. Remember, the thing in parentheses never ever changes. And since I need 3 of them, I'm going to write a 3 on the outside of the parentheses. Fe2, SO4, 3. There we go. Now we've written out our equation, and we used one of the transition metals that has more than one charge. So the nice thing is with that Roman numeral, it tells us exactly what the charge was. It was 3+. So we're going to definitely need to practice this more, but this is a great introduction to how to write formulas. There are tons of things on YouTube as well online where you can look at to write different formulas and to get practice with it, but we're going to practice in class as well. Now remember, we've been focusing on ionic compounds. These are different than covalent compounds. Eventually we're going to mix those two together because they're found mixed up in nature. But for now, this is a great start. Hang in there, science fam, and we'll get through this together. Be well.